So, sensory processing is an area that we could spend a lot of time talking about. Um, but basically, where it all fits in together is that it's one of the base skills that we all need to be able to develop um, all the other body skills that we need to do all the activities in our day.
And how we understand, view, perceive the world is all through our sensory systems. And looking at this pyramid of learning, when you think about our central nervous system, the sensory system is the base system that everything else is built on. So we're starting with sensory system, then we move up to sensory motor, perceptual motor, and up to this cognition and intellect at the top. And those top three skills, these are the ones that we generally get our referral areas, or the areas that teachers and parents are wanting to improve. So those areas of academic learning, so those school skills, behaviour, and the daily living activities. But we're not able to work on those areas explicitly without first looking at these underlying blocks underneath.
Kate sometimes describes this pyramid as a Jenga tower. So if you pull parts out, it's going to leave big gaps and make it really unstable. And the more parts that are pulled out, the more unstable it will be. So that's where we need to put those blocks back in to restabilize it, so you can get to the tippy top of that pyramid. So everyone has 7 senses. Commonly you hear just the 5, so your touch, smell, hearing, taste, and vision. But there's 2 other more hidden ones that also have a really important role in our body. So that's proprioception and your vestibular input. So maybe explain those ones first, because they're probably the ones that you know the least about. So proprioception is when... Oh, there we go. Proprioception is how we know where our joints and our muscles are in space. So we need this information to know exactly where we are. So it combines with all our other senses to help paint that whole picture. This one is, you can test it by if you were going to stand somewhere and someone was going to put your arm in a position, you would be able to tell them where your arm is exactly without seeing where your arm is.
So proprioception is really important for us being able to move around and perceive what's happening around us, because if you don't know where your body is in space without using your vision alone, then you're not going to be able to navigate your way through a room. So quite often we see kids and adults who have trouble with proprioception, like they end up with bruises all around their legs because they're often walking into different things, because they've not got that concept of where they are in relation to things that are around them. It's also it can feed into poor posture. So if you don't know where your body is in space, you might not be able to sit upright in the chair and be in the correct position, an optimal position for that. It helps us to manipulate objects and use objects. So knowing where your fingers are and having perception of that, getting that feedback helps you to hold a pen, hold a fork. So this kind of paints into a picture of some of the kids who might say have troubles with proprioception in general. And then, yes, some of the other finer things you might see is around that pressure on the pencil. So like kids are really, really hard putting too much pressure or not putting enough pressure on a pencil.
So if someone is talking about getting more proprioceptive input during their day, that means more moving around, crashing, running, jumping, all of those sorts of bigger movements where your body is using all your joints and your muscles.
Yeah, because some of these kids who are trying to get proprioceptive input go for the really deep hugs, or they throw themselves onto the floor or throw themselves onto the couch. Like they're just trying to get that really heavy impact onto their muscles and joints, so that their muscles and joints are going, here I am, this is where I am, so that they can get that input throughout the day.
The vestibular input is, it's quite a complicated sensory system, but it's essentially for letting us know where our head is in relation to our body, and in relation to Earth's gravity as well. So it's really, really key in your sense of balance, but it also helps with spatial awareness and body awareness as well. So it provides us information about where we're going, how fast we're going, how slow we're going, which way we're pointed, whether we're going forwards or backwards or side to side, and where we are in relation to other objects around us. Or, for example, if you're standing on a hill versus standing on a flat piece of ground.
When it comes to the direction, it makes me think of so the fast or slow or the direction, it makes me think of some of those kids that just don't have a slow button, like they're constantly running fast. There's no walking, it's running everywhere to get there, trying to move really quickly all the time, or kids that just move really slowly. So it might be that they're not wanting that vestibular input, they're just moving really slowly because their brain can't process that sort of information. Some kids who just love being upside down and often hanging upside down when you think about the head position, or love climbing as well, being off the ground or not like being off the ground. Quite a few kids get a bit that sort of gravitational insecurity around being off the ground. And the orientation in space can be they don't know where they are in relation to the things or people around them. And sometimes this can often be seen in the handwriting as well, like their letters don't have any orientation in space or any relation to the line, and can be big and small in different sizes as well. So sensory processing is probably best described using this visual where we're looking at the 7 senses up the top. So we have touch, smell, vision, movement, hearing, taste, and body awareness. The technical term for movement is vestibular, and for body awareness is proprioception. So all these inputs come into our brain, into the central nervous system. Our brain processes that information. We then understand what it is. We then have the behavior following that, and then that's what leads to development over time. So an example would be with smell. So we might smell something cooking in the kitchen. So our brain interprets that smell, and then our understanding is that mum's making pasta tonight, and so our behaviour is that we might go into the kitchen to take some.
So within all of those different senses, there's different thresholds for everyone. So we all need different amounts of input from each of those senses to be able to register that sense is being triggered, and for us to go through that system and do something about it.
And probably the best way to think about it sometimes is intensity, because we all experience things in different intensity, and it's whether our brain picks up that intensity or not, or how much it needs to be able to register that it's there. So things like taste, if you think about chili, some people can have a little bit of chili and it doesn't do anything. They don't even notice it's there. And other people can have the same amount of chili and it's a very high intensity for them. So the input, the experience was, well, the sensation was the same, but the interpretation and the recognition of that was very different. So that's their experience of the intensity. So some kids with movement, for example, need a lot of movement to be able to register that they're moving, whereas other children, just moving makes them feel seasick, so because they experience it in different intensities.
Another example is around smell. So some people love really scented candles and have incense burning in their house, where other people can walk into that house and then just become really frustrated or angry, or just they can pick it up so quickly, and then that leads to different behaviours compared to the person who is lighting them, because it helps them to feel calmer and more relaxed.
Another common one that we get a lot of referrals for is the hearing. Some people quite like to sit in a busy cafe to work, and that's how they feel like they can concentrate, and other people, they need to be in a library where it's dead silent and quiet. We see this often in classrooms where some children, they thrive on the busyness of the classroom and the noise, and they don't even notice that there's a lawnmower going on outside or things happening in the background, whereas other children, they can't focus on what the teacher's saying because the child on the other end of the classroom is whispering something to their friend. Like, they're very sensitive to the hearing because that intensity is a very different experience for them. So it's sort of looking at what's happening for the child or person on each of these sensations, and to sort of map out what is either overwhelming their, like having too much information coming in, so which means that they can't process it properly, or perhaps there's not enough information to even trigger the brain to know that something's going on around them.
And all this information first comes into your brainstem, apart from smell. And so your brainstem is also where you have your fight, flight, fright response, and your digestion and heart rate and all those other really base functions. So it's all mapped in that area, and then it goes higher up into your brain, which is where you have that understanding.